10C looks at mensuration. Mensuration is basically the maths behind perimeter, area, and volume. 10C is going to focus on perimeter and area. We'll look at volume separately a little bit later. The perimeter of a shape is basically the total distance around a 2D shape. So it's the outside edges, adding this, and this together and calculating that edge. If it's a circle, then the perimeter is called a circumference and not the perimeter, but you are after the same thing, the outside edge. So for this question, we're going to look at example 7. Find the perimeter of the shape. First thing to note is that 16 is also here. So if you've got one here and one here, you do actually have the same length. That's due to these two lines, just like the one line means that this side and this side is also 12. So I can put in those extra, I suppose, distances, and then I can just calculate my perimeter. I've got 2 lots of 16, so I'm going to times it by 2. 2 lots of 12, so times that by 2, and then just add the 25 on the end. You can use a calculator or you can just do it in your head, whatever's easiest. You get out 81 centimeters for that first one. Note the centimeters, you do need to have units attached to questions, and in this case that's, again, centimeters. Area. Area is the measure of the region enclosed by the shape's boundaries. So you can have simple shapes like a rectangle, and you're looking for the area, which is this region inside. There's some formulas for it. So perimeter, the formulas for a rectangle, the perimeter is 2L plus 2W, or 2 times L plus W. Both of those will work. And the area formula is length times width. There is actually a sheet in Compass linked down the bottom, which has a bunch of different formulas for area, perimeter, and volume. My advice is that is in your rules book somewhere. So you might want to have a look at that after this tutorial. So for this example, we're asked to find the perimeter of the rectangle. Again, it's just like the one above. We're going to have 2 times length times width. So I'm actually going to use the formula in this case. 2 times 12 plus 2 times 5. So 24 plus 10 is 34. And this is centimeters. So box that. Parallelogram. So the parallelogram, which I've just gone past, has a similar formula. Trapezium. Again, we've got some formulas attached to that. The difference for trapezium is actually to find the perimeter, you just need to add all 4 sides. There's no nice formula for that. You just need to, I suppose, do the hard yards. The area of a shape. So find the area of the given shape. This is a trapezium where the height is 5.8. We can say A is 4.9 and B is 7.6. So we can write the formula 1/2 A plus B times H, and then substitute in A, B, and H. So 1/2 4.9 plus 7.6 times 5.8. That's something I'd put into my calculator. So chuck it in as 0.5 times 4.9 plus 7.6 in a bracket. Make sure you do have that bracket. And then I'm going to times that by 5.8, and that's going to give me out a result of 36.25. This is centimeters squared, and you do need that squared because it is an area. We've got the formulas for the area of a triangle and the perimeter. The perimeter is basically add up the 3 sides. There is a special formula for the area of a triangle. We're used to having this formula of a half base times height. That's the one we've traditionally used a lot of. However, there is a formula called Heron's formula. You can use Heron's formula if you've got all 3 sides, no other like heights or anything, but the 3 side lengths, if you've got that, that's what this formula is here. So the way it works is basically you need to half the perimeter. So calculate the perimeter, half the perimeter, and then you need to substitute in. So your S is half the perimeter, and A, B, and C are your side lengths. We're going to do an example that's going to use Heron's formula. Heron's formula. In this case, the side lengths we've got is 3, 5, and 3.5. First step, let's find out what S is equal to. So 3 plus 3.5 plus 5 divided by 2. Just going to chuck that into the calculator. And I get out a result of 11.5. and then divide it by 2, so I get 5.75. So when I go and use the formula that I've got up the top here, that's what I substitute in for S. So 5.75 bracket 5.75 minus 3, 5.75 minus 5, or 3.5, and then 5.75 minus 5. And then take the square root of all of that. That's something to throw into my calculator. Make sure that when you put it into your calculator, you are checking that you've got nothing wrong. So it's very easy to make a really small mistake. Please make sure your decimals are right, your numbers are right, your brackets are right, etc. Getting out a result of 5.17, and this is an area, so this is going to be centimeters squared. The question states 2 decimal places, so make sure that you do it to the appropriate number of decimal places. So the next example is more of a practical problem. We have a display board for a classroom which measures 150 centimeters by 90 centimeters. So just drawing a quick diagram. It's always good if you don't have a diagram for measurement, trigonometry, anything that you can draw a diagram basically. Part A is asking us, or we're told that a ribbon costs $0.55 per meter. And how much will it cost to add a ribbon border around the display board? So first off, we need to know what the perimeter is. Note that this is per meter, $0.55 per meter. So I'm converted my 150 centimeters and 90 centimeters to 1.5 and 0.9. I'm going to use that formula for the rectangle, or the perimeter of a rectangle. So 1.5 times 2 plus 0.9 times 2. And if I put that into the calculator, I'll get out a result. So 3 plus 1.8 is going to give me 4.8. The question actually asks for the cost. So you need to take that distance of 4.8 and times it by 0.55, which is the cost per meter. This gives me out the result of 2.64. This is a dollar amount, so $2.64. Part B says the display board is to be covered with yellow paper. What's the area to be covered? So we need to do an area of this. It's just length times width, so 1.5 times 0.9. And then this gives me out the result of 1.35 meters squared. Note I've gone in meters because this says give your answer in meters squared, which again says that I use 1.5 and 0.9, not 150 and 90. Answer correct to decimal places, and that question is complete. Red box the answer. All right, the next one looks at composite shapes. Composite shapes are basically a shape that's made up of 2 or more basic shapes. So this picture of a house sort of is a rectangle and a triangle on top. So anything that's made up of 2 or more basic shapes. You could also cut out shapes. So you could have a circle in here, for instance, where you want to know this area minus the circle. Just a kind of a different way to do it. All right, this example is saying that a gable window, so this is the window, at a reception venue is to have LED lights around its perimeter, not along the bottom of the window, so not here, just around here. And the height of the room is 2 meters, the window is 2.5 wide, and the height of the gable, this part here, it's like the triangle part at the top, is 1 meter. And this is all shown in the diagram. So what I basically got out of this is that the only part that's important as far as information goes in that whole first sentence or first paragraph, whatever, is not along the bottom of the window, right? That's basically the only thing that's important because everything else exists in that diagram. So we've got everything. Now, part A says calculate the length of the LED lights needed, correct to 2 decimal places. And then part B is an area question, which we'll deal with in a second. In order to do part A, you do need to know what this distance here is. Okay, so what is this, I suppose, angle part? The hypotenuse, if you want to look at it as a right angle triangle. And in fact, that's how we need to look at it, as a right angle triangle, because we can use that to calculate that side length. So our first step is actually going to be to calculate that X value, or what I'm labeling as X. And X is going to be equal to 1 squared, which is the height here, and then half of 2.5 squared. Take the square root. That is Pythagoras' theorem to calculate this side length given a right angle triangle here. And then when I do that, I get out a result, and that result is the, I think I've actually got it in my calculator. Either way, basically I'm doing 2 lots of this. So 2 lots of this length, which is 2 lots of this, plus the 2 here and plus the 2 here. So I've got my square root of 1 plus 2.5 divided by 2. I've timesed it by 2. I'm plussing 2 and I'm plussing 2. Maybe pause it if you're not sure. Have a read of that. I get out 7.20 meters. So that's how many, or the length of LED lights that I need correct to 2 decimal places. The 0 is there because I need it for 2 decimal places. All right, part B. The glass in the window needs to be replaced, and we're asked to find the total area of the window correct to 2 decimal places. Always draw your diagram so you can split it up. So I've split it into a rectangle and a triangle. So 2 times 2.5, this is the area of the rectangle. Area of a triangle is given by half base times height. So 1/2 2.5 times 1. And then just putting this into my calculator to get out my result. And I get, it's coming, I get 6.25. This is an area, so 6.25 meters squared. Red box it, and I am complete.